All right. All right, everybody. We're going to do Fall 19 Final Exam Study Guide numbers 16, 17, and 44, I think. Yeah, 16, 17, and 44. We have to know that we're making what's called a vicinal halohydrin here. Halohydrin. You don't need to tell me that name. And it's adjacent atoms that have both an alcohol, which is a hydrin, and a halogen. And how do we do that? It's a Markovnikov OH-Br combination achieved by reacting with bromine and water. They're all good questions, by the way. I could just change the product to make each answer correct. And since we're here, if I want A to be the right answer, here's the product. If goes to BR, then it's A. If it goes to just BR here, it's B. And if it goes to this, and the double bond stays, and you get an allylic bromine, that's the one with the initiation propagation, right? Br2 and heat. So each of those is good answers for different questions, except for C, which is for this question. And in this one, which is the best choice of reagents to perform the following transformation, is a very good question. A lot of you are thinking water and sulfuric acid. I'll tell you what A gives you. And it isn't what's drawn. The OH ends up here, and a methyl moves here. Rearrangement because of carbocation on the carbon, one away from a branched carbon. So A does not give the right, just want that to be very clear. A gives that which is not what's pictured. B gives what's pictured because mercury triangles suppress rearrangement. Yes, some of the things weren't mentioned in class, but there's this thing called a textbook where they are. And yes, mercury suppresses rearrangement. And then BH3, H2O. So C would give a different result, which is not the result pictured. No rearrangement here either, but you get the anti-Markovnikov alcohol. And D doesn't give anything remotely like the result we are looking for. D gives a vicinal dihydroxylated compound. Wow, that's a lot of words. Vicinal diol. There, that's D. Not the right answer either. So B is the right answer, and we talked about why. Now, when you're doing the new acids with sulfur involved, the only way to remember it and it's easy, is the names are alphabetical relative to the number of bonds to oxygen. The one with the E, sulfenic, will have the least bonds to oxygen. Sulfinic will be next. E, then I, then O. We already know sulfonic acids like toluene sulfonic acid. Here's how I do these so I don't mess up. The enic is the one with the least bonds to O, it's 2. I just do them right under the descriptions here. The onic is the last one, it has 3 bonds to O. And the inic has onic has 5 bonds to O. 1, 2, 3, 4, 5. And the inic has 3 bonds to O. And it is 3. Not what? Sulfonic was 1. What am I doing, dudes? Sorry. It's a good question, though. What the heck was I doing? Sulfonic is the first one. It has the most bonds to O. Sulfinic is the one with 3 bonds to O, which is 3. 2, 1, 3 is your answer. And this looks like a perfect question. It's got 6 answers. And there you go. So we got all of those, and we're done with that. And in here.